Eric Eisinger suggested fade back for photochromic, so just to make things a little simpler, we'll turn the AR feature on so it's nice and clear and you can see. So photochromics, when you turn it on now, the fade time will start at the 10%, which is the average photochromic transmission, and go up to roughly about 80%, which is what you'll get in a sunny, cool environment. And as you can see now, there is a clear to dark timer at the top, which goes from 0 to 30 seconds to illustrate darkening over time. Also, you could see, Eric, that there is a fade button now, or a fade check mark, and that fade check mark allows there we go, allows the fade to go in the opposite direction, starting from 80%, going back down to 10% in roughly about a minute to a minute and a half. I shot for the middle of that for a minute and 15 seconds, just for illustration purposes, and also so that patients don't have to stand around waiting extra long. The fade isn't a linear fade, so it's not fading equally over time. It's actually fading using an easing function over time, which is very similar to the way the photochromatic chemicals work. As the top layers of the photochromatic chemicals fade back, then the bottom layers fade back, so on and so forth, till you get all the way to clear. Same when you darken. It darkens fastest initially, since the underlying photochromatic chemicals receive some of that UV light. They turn darker, so do the topmost layers. As those topmost layers darken, they prevent that UV radiation from reaching the layers that are more in depth inside the lens substrate. So what ends up happening is the underlying layers take longer to fade. So as you can see, it all kind of works in unison now. Again, all the colors are still there.